Upload your doubts on the app to get video solutions.
A block of mass m takes t time to slide down on a smooth inclined plane of an angle of inclination theta and height h. If the same block slides down on a rough inclined plane of same angle of inclination and same height and takes time n times of its initial value, then coefficient of friction between block and inclined plane is out of these options. Okay, again I'm repeating, what is happening here is we have a block of mass m, okay, and it is going through it, okay, on a smooth inclined plane. In the first case it is taking some time, okay. Now in the second case, what is happening? It is again going through this, but this time there is some friction offered by this inclined plane, correct? So the distance it is traveling in both the cases is same. Again I'm repeating, the distance it is traveling in both the cases will be same. So in the first case, let's see the first case. If a block is placed on an inclined plane, okay, it is going down because of an acceleration. And what is that acceleration? Let me remind. If this is a block and it is traveling downward, okay, it is going always downward because of an acceleration, and that acceleration is nothing but g sine theta, correct? Where theta is what? Theta is this angle, okay. G, acceleration due to gravity, is downward, okay. So we can split the components of g. What are those components? One will be g cos theta here, and here it will be g sine theta. This is acceleration downward, correct? And this is responsible for the block to go down, clear? If the height of this inclined plane is h and this part is length L, okay, this is the length L, then we can figure out that sine theta is nothing but, what is sine theta? Perpendicular over hypotenuse h by L, correct? Or L, the length which is travelled by the block, will be h upon sine theta. So L will be equals to h upon sine theta. Now how much time it will take to slide down? The time taken by the block to slide down this length L will be found using our equations of motion, correct? So what is our equations of motion? S equals to ut plus half at square, and I assume that initially it is not thrown with some velocity. So u is 0. So S will be equals to half at square. I hope this is clear. So time t square will be equals to 2s upon a. So t will be equals to root under 2s upon a. This is the time taken by the particle on the inclined plane. Now what is s? S is the distance it will travel, right? So this s is L, length a, and acceleration a is g sine theta, correct? Let's substitute that and find the time in the first case. So t will be equals to root under how much? Our 2 into, let me recheck the formula, 2s. What is s? It is L upon how much it is? G sine theta, okay. It is g sine theta, correct? 2s upon a. And what is L? L is h upon sine theta. We can see that over here. L was h upon sine theta. So let me just write here the time when it is falling on the smooth inclined plane, it will be 2 into h, okay, upon sine theta into g sine theta. I hope this is clear, okay. So time t will be equals to root under 2h upon g, and let's take the sine theta outside. So sine square theta, it will be 1 upon sine theta over here. I hope this is clear. This is equation number 1. Now if it is falling on a rough inclined plane, there is a force of friction which is acting in the opposite direction. So if this is a rough inclined plane over here and the block is going down, it is going down because of g sine theta here, and there is a force of friction which is acting on the opposite direction, right? Now what is the frictional force? Let's figure out the acceleration from that expression. So frictional force acting in the opposite direction will be how much? Mu into normal reaction. And what is the normal reaction here? If we have done inclined plane, if n is this n is equalized by what? It is mg cos theta, so it will be mu mg cos theta, correct? This is the frictional force. So what will be the acceleration due to the frictional force? It will be A, that is equals to F by m. F by m. 1 second. So let me just remove this and write it over here. So acceleration A will be equals to F by m, that is equals to mu g cos theta. This is the acceleration due to the frictional force which is acting in the opposite direction of the block. In the first case that was smooth, now it is rough. So since it is rough, this acceleration will try to slow down. Okay, so it is mu g cos theta. Now the net acceleration of the block on the rough inclined plane will be our A dash, and that will be equals to how much? G sin theta minus mu g cos theta. This will be our net acceleration, right? Now we can find the time period again. So what will be the time period of fall in rough inclined plane? It will be t dash, and using the same expression it will be root under, how much it will be? 2 and L. L is how much? H upon sin theta, same thing. And what will be the new acceleration? The new acceleration will be A dash. So let's substitute. T dash will be equal to root under 2h upon sin theta into, what is our A dash? A dash is g sin theta minus mu g cos of angle theta. Okay, this will be our expression. Now if this is our new time period, we can simply find our relation. So what is our relation? Our relation is the new time period t dash is n times the previous time period t1, correct? Next, now what is our t1 value from equation 1 and t dash value? Let's call it as equation 2. Let's substitute it over here. So t dash will be root under 2h upon sin theta into g sin theta minus mu g cos theta. This will be equals to how much? N times t1. And what is t1? Root under 2h upon g and sin theta. So let me write here this over here. 1 second, let's remove this and let me just write it here like this. Root under 2h upon g and into 1 upon sin theta. This will be our, and where will be n? Let's multiply the n over here. Okay, so this is our relation. Let's simplify and get the value of mu. The mu will be what? Mu is the coefficient of friction. So square both the sides. On squaring both the sides, it will become what? It will be removing the roots. It will be 2h. Okay, this size, the pen is very small here. Okay, now this is better. Okay, so removing the roots, it will be 2h upon g sin theta into sin theta minus mu cos theta, and that will be equals to how much? N times 2h upon g sin square theta, correct? Now let's cancel out the terms. G will cancel out both the sides, 2h will cancel out both the sides, right? And on squaring, this will become n square. Okay, so what we left here on the left hand side, we left with 1 upon sin theta into sin theta minus mu cos theta, and on the right hand side it will be n square upon sin square theta, correct? So here we will cancel out sin theta with sin theta. We left with 1 upon sin theta minus mu cos theta, and that will be equals to how much? N square upon sin theta. I cancelled out sin theta both the sides, one of them. Clear? Now let's cross multiply. So on cross multiplying, it will be sin theta, that will be equals to n square sin theta minus mu times n square cos theta. Let's take this n square sin theta on the left hand side. It will be sin theta minus n square sin theta. Okay, sin theta or instead better we take mu n square cos theta on the left hand side so that it becomes positive. Mu n square cos theta, and that will become n square sin theta minus sin theta. Let's take here sin theta common out. This will become n square minus 1 and mu n square cos theta, correct? Let's take it inside. So mu will be equals to sin theta divided by cos theta into n square minus 1 upon n square, correct? So that we can write it here as sin theta upon cos theta is nothing but tan theta. So mu value is tan theta, and let's take that n square minus 1 upon n square inside. So it will be n square upon n square minus 1 upon n square, and that is our giving us final value mu equal to tan theta into 1 minus 1 by n square. That's our final result.
Watch the complete playlist on the app Pions. Download the app now.